In 2006, also Yahoo had a series of aerial imagery for the area for globally in that case, and they released this for use to the OpenStreetMap community, meaning people could actually go on and digitize. So they could say there's a road here based on how they see it in the imagery, and they could actually create it by not having to be on the ground in that case. That was a big step up for OpenStreetMap. In 2007, we had about 1 million points, GPS points that had been contributed by individual users. 2007 was also the year that the Tiger data was released. Tiger data came from the US Census, and it was basically public roads, buildings, footprints, state boundaries, county boundaries, and so on. And there was a big boost for OpenStreetMap. This data was then published to OpenStreetMap. So we had a whole series of freely available US Census taxpayer-paid data that was actually available for us to use online. And in 2010, Microsoft kind of joined the project by freely offering their aerial imagery for us to digitize, which was a better base map than we previously had from Yahoo in this case. A bit sort of by the numbers, just to give you sort of a sense of what's happening. As of yesterday, this is the most recent numbers I have, 3.6 million users accounts. A portion of those are active, but these are the number of accounts you see. 5.6 billion uploaded GPS points, 3.8 billion nodes. Nodes are individual points on the map that you would say draw a road network. It's made up of a series of points that have been linked together. The ways are actually the lines between the points. So we have about 400,000 or 400 million ways. And then yesterday there was 70,000 nodes created in a single day. That's kind of normal for OpenStreetMap, the amount of data that's being generated. So I just kind of wanted to show the amount of content that's actually being created in OpenStreetMap. This isn't just a small project, it's a very large project, similar to the size and scope of, say, something like Wikipedia, but from a mapping perspective. Just to give you a small demo, if this works. It's always the question. And then I'll just speed it up to give you some idea of the OpenStreetMap community. Let's look at that. So it's kind of boring for the first years. Not a lot going on. Then you start to see the outlines of countries, and it gets a little bit more interesting. But this is actually showing sort of between 2006 and 2016 all the edits that happened. We have timestamps for when things were edited, and you can actually start to see things start to show up. It'll actually, by I think it's late 2008 that we see the Tiger data start to make it in to the map here. I'm gonna fast forward a little bit more. Suddenly you'll see the US just goes crazy. There you go. So that was the Tiger data, that was the US Census data that was released and immediately uploaded to OpenStreetMap. And then as the years progress, you start to see sort of more and more activity happening in contributions. Clearly, there's a bias towards certain parts of the world where this is being created and who's actually contributing this data. But as the years go on, you start to get a big, like this becomes pretty well mapped in a lot of cases, and you start to see more and more NGOs and government groups start to focus on sub-Saharan Africa and some other places that need further mapping. And I'll talk about that a little bit more in a few seconds. But I just kind of wanted to give you a general idea. It's a pretty cool video if you've got 10 minutes just to sit around and watch a video. But I'm a nerdy guy, so I like that kind of thing. Where were we? View, full screen. So one of the examples that we often talk about, or sort of waving the flag for why OpenStreetMap is a useful tool or useful platform to contribute data, comes back to 2010, the Haiti relief effort after the earthquake that happened in Haiti. A really good use case for this was that this was what the map looked like immediately after the earthquake on Google Maps. And this was sort of traditional mapping techniques based on authorized users that work for Google, uploading and updating the data based on the records they have. And this is what the map looked like on OpenStreetMap. And so this was the contributions from individuals. So immediately after the earthquake, there was this kind of groundswell effort of people that got together, had mapping parties, or we call mapathons, people that spoke the language, people that had been there before, people that had satellite imagery. I think Digital Globe released a satellite imagery right away, and you were able to map things like hospitals, aid centers, things that were really important for on-the-ground efforts from USAID and the Red Cross and these sorts of things. So it's sort of a more timely response, and it's not saying Google didn't make an effort, they just didn't have the bandwidth or the human power to actually create a lot of these elements. So you kind of see a difference in sort of the use case for why OpenStreetMap matters in a lot of these cases as well. Missing Maps is another project that's sort of funded by the Red Cross, or is funded by the Red Cross, I should say, as well as some other organizations, that's really out there to incentivize users to actually contribute to these things. So if you're a government group or you're an NGO, you can sort of submit a project and say, I'm interested in having these areas mapped. They aren't currently mapped. Nobody has street networks or road building or building footprints for these areas, but it's important for my project to have these. And then users will go on Missing Maps, click a tile that needs mapping, and then spend some time mapping it all out. So it's kind of a way of organizing, prioritizing what's important, what needs to be mapped for this certain project as well. I should sort of, this is a plug for MapSwipe. It's an app that they created on your phone. You can just basically look through tiles. If you see a building, you just hit it and say, yeah, I saw a building, and then pat it through. So rather than playing, I don't know what you play, Angry Birds on your phone nowadays, you can kind of contribute back to the open source community or global aid in this case, and use this for like mapping out malaria. So they need to figure out where there's small villages that haven't been mapped by satellite imagery. And you can just sort of search through imagery and click on where these projects are. It's kind of a fun little tool. Missing Maps has also incentivized this by more kind of a school children idea for saying, we're going to give you badges or points depending on how many edits you make, how many buildings you add, updates you do. They've realized that from social media like Foursquare that badges and these kind of gamification aspect really works, and they can kind of have people compete against one another to see who adds the most miles of road to a new country or something like that. So a fun project, and if you're wondering why people contribute to it, this is one of the things when we talk about incentivization, specifically like with Wikipedia, this has a similar effect as to making people or forcing people to collaborate or work with one another on these projects. So the project, this sort of gave you a background of OpenStreetMap, and I'm happy to answer any more questions you might have about OpenStreetMap. But one of the things that I was really interested in my research was sort of the next frontier of crowdsourcing or mapping projects. Open geodata is really on the sort of elevation side. That's kind of how I viewed it. OpenStreetMap currently doesn't have a lot of elevation values. There's a few buildings in downtown central cores of cities that have a number of floors in them or some indication of elevation. But there's not much in terms of elevation for road networks or elevation for mountaintops, these sorts of things. So my project was really, or this project was really focused on using crowdsourced data or user-generated content to actually access some of these elevation values and update the map, so to speak, update OpenStreetMap with some of this elevation stuff. So just to give a background on elevation data, when we talk about geographic information, there is publicly available elevation data for the world. In 2000, the SRTM data released 3 arcsecond, which is approximately 30 meter resolution worldwide elevation values. So it's really coarse resolution, but at least there's some elevation values. In 2014, they revised this to be 1 arcsecond, so 30 meter worldwide resolution. In the US today, we have approximately 10 meter resolution for most of the US, which is a reasonably good elevation for larger scale activities and things. And in some regions, we have access to LiDAR, which is aerial aircraft will fly over with laser imaging and return pulse values to tell you how high things are. This could be a meter or sub-meter, down to quarter meter resolution of really high resolution elevation data. The difficulty with this is that most of this LiDAR data is not public. People will fly these flights and it costs a lot of money, so they tend to hold on to this data if you're a forestry company or a mining company, for example. Washington, D.C. is in a situation where they do have publicly available data, data.gov. You can actually access a lot of their LiDAR data, which is quite nice. But a lot of places struggle to get really high resolution aerial elevation data. So the motivation really for me in doing a lot of this was I came from UC Santa Barbara. I did my PhD and postdoc there, and one of the issues in the Santa Barbara foothills is that the fire trucks or the fire station, the operators of the fire trucks don't necessarily know which houses they can get to in case of a fire. There's a lot of really windy, strange elevation patterns that happen in the roads in the foothills of Santa Barbara. A lot of canopy cover, so you can't get a lot of really good high resolution imagery of the area, so you don't know what's necessarily there. And I was really surprised to hear that, you know, the fire department doesn't necessarily know what houses they can get to in this case, which is kind of odd. So one of the things we wanted to do is say, well, can we actually use cyclists, people that go out and ride their bike, and upload GPS tracks to actually get in situ elevation data for these areas? areas. And it turned into a pretty interesting project that we'll talk about right now. So we have, the sort of focus in this was realizing that we have an incredible amount of user-generated content, social media, data that people are contributing. You know, this Web 2.0, post 2.0 world where we're producing and consuming incredible amounts of data. And this is also true not just for regular social media data, but also for, you know, social fitness tracking applications, right? So people are wearing smartwatches, have Fitbits on, have increasingly amount of data that they're choosing to share about their personal activities is pretty shocking. And there's a whole massive aspect of privacy that my other areas of research talk about, but I just wanted to give an idea of the kind of applications that are out there. You have things like Garmin Connect, where you can upload your track of whatever you did that day, share it with your friends, and you can compete with your friends to see who's doing certain routes faster, these sorts of things. And there's like an application like Strava, which is the sort of main focus of my work. And have any of you heard of Strava before? Okay, so Strava is a social sort of the prototypical social fitness tracking application. You would put a bike computer or a watch on, you go for a bike ride, it basically records your GPS, maybe your elevation values, maybe your heart rate, whatever you choose to give it. And you come back home and you upload it to this website, Strava, and it allows you to compete against your friends. Say, I did this segment faster than you did, or whatever the case may be. The really interesting thing about Strava, from my perspective, is just the sheer amount of data that's actually being uploaded to it. So this is one segment. This is in Victoria, British Columbia, sort of around the water. It's a very small segment, actually 1.6 miles. It has had 40,000, almost 41,000 people, or different activity attempts at this. Meaning about 40,000 times someone got on their bike with a bike computer, rode this segment, came back and uploaded this data. Maybe not an individual, but a group of different people have done this. So we have this basically across the US and increasingly globally that people are contributing this kind of information. So the question for us is, can we use these GPS points that have an elevation value to actually come up with a digital elevation map of a higher resolution for the area we're looking at? This is sort of our sample site in Santa Barbara, was to focus on these three sort of segments that are in blue, and then I also took two segments from Washington, D.C. that I just wanted to see if there was a big regional difference, which there wasn't, but I just wanted to make sure we weren't biased by the data that we were looking at. This kind of brown, or this sort of gray-black area is actually a LiDAR map. You can kind of see street networks. The darker the color, the lower elevation, the lighter the color, the higher the elevation. And so this was a data set that we had commissioned, that we paid for, that flew over parts of Santa Barbara and got us 1 meter resolution elevation as our ground truth, that we knew that was the actual elevation that we had. And then we had these segments. Looking at it in a different light, this is if you actually map this to a digital terrain model, you can actually see the same thing. These are our segments. We had one segment that was in the hills. We had one segment sort of along the coastline, and we had another segment. This is actually goes under an underpass, so it's a sort of a weird use case that I'll talk about in a second as well. If we actually took a sample of about 10,000 activities, so this is people that have gone on their bike ride, they've come back, uploaded it, and over one specific segment, we took about 10,000 of these activities and said, well, let's just map these out and see what these look like. And you start to see some really interesting things in that the road here is kind of in pink or white, maybe kind of hard to see, but the individual segments are these sort of turquoise bluish lines. And you start to see some really strange errors, right? These are typical GPS multipathing errors. We know that somebody's actually not riding their bike through someone's house or, you know, in a straight line up that coast like that. We know they're actually multipathing errors, so this is an issue with GPS units, especially in sort of heavily tree canopied areas. And what we were basically looking at is to see what's that sort of variance in the road we're looking at. Now, this is actually a project that Strava itself has been working on. From a horizontal perspective, not from an elevation or vertical perspective. They're looking at all the tracks that their users upload, creating heat maps of it, pulling up the sort of median central value from those, and contributing it back to OpenStreetMap. And so they're able to get more refined models for the road networks by doing this. Say, the Tiger data that is uploaded from the census might be very coarse resolution. This gets much finer resolution for what we're looking at. But what I wanted to do is say, well, can we actually look at this from an elevation perspective? And elevation is considerably more complicated because you're dealing with a lot of really noisy data, right? To get a fix on the surface of the Earth from a two-dimensional set, you need three satellite signals from three satellites in order to triangulate or trilaterate your location. To get in elevation values, you need many more, 2 or 3 to actually get something of relatively good value. The difficulty here is that each of these different devices, so if you're using a watch or you're using a GPS device, they range in the sensors that they use to collect the elevation data. Right, so you have your Garmin Edge 500, which is the most used device in our sample set, and then which has a barometric altimeter, which uses barometric pressure to determine your elevation. And then you also have like the iPhone app or the Android app, which uses just the GPS elevation. And GPS elevation by default is horrible. It's a very typically not a very good measure for determining someone's elevation. Barometric altimeters, on the other hand, because they use barometric pressure, are relatively good. So their precision is quite high, but their accuracy is quite low. So relative from point to point, they actually fluctuate really well, but how well they map to the actual ground truth data is another question. They're not as good in that case. So what we did, just to show a couple graphs here for one specific segment, and this is a profile of a segment. We were looking at a road segment here. If you look at the upper left corner, it's the Garmin Edge 500 device, which is the computational device for the bike computer. These kind of gray lines are the individual cycling segments. So what you see is there's actually quite a range of the profiles, right? The trends are good, so the actual from point to point look reasonably good, but how accurate they are in terms of their height can just generally be off quite a bit. What we actually were doing in these cases, we just took the median value from those, which ended up in our blue line there, the mean value in red, and then the actual ground truth data with the black line showing the elevation value for the actual slope in that case. Now if we compare this, so these are the barometric altimeter devices, means that the cycling computer had a barometric altimeter in it. The flip side of this was the Android and iPhone devices do not use a barometric altimeter. They use a GPS device to determine elevation, and they're way off. So that you can see quite a bit of difference in how the elevation values map to the underlying truth-based elevation values for the LiDAR data, and our values are quite a bit off. The interesting part we see here too is these green lines, and I'm not sure if you can see it back there, but the green lines in here are actually what I mentioned previously, the publicly available national elevation data at 10-meter resolution accuracy. And if you actually look at those green lines, they're kind of hard to see here, but they're actually quite a ways off from what we would expect as well. So while the resolution might be a higher resolution than say the 90-meter resolution data, the elevation values in terms of their accuracy are quite poor. When we actually map this, and this is kind of the results slide, so to speak, if we took 2 segments in Santa Barbara and 2 segments in Washington, D.C., and we were to compare our, what we call ICE in situ elevation data, the median value from our cycling measurements, and the national elevation data, which is the sort of traditional baseline elevation data that we have from SRTM data, we see that on average, our actual median value is quite a bit better. And we use 3 measures for this, root mean square error, Hausdorff distance, which is basically the maximum offset between the 2, and then earth mover distance, which is essentially the cost to translate one signal into another signal. To sort of sum that all up, if we sampled 350 million 3D location fixes, so we took all this GPS data that was contributed by individual users that were cycling in these segments in Santa Barbara and DC, and then we calculated the root mean square error from our LiDAR ground truth data, our average was about 3.11 meters off. So on average, we were about 3.11 meters difference from our ground truth data. If we did the same thing but using the national elevation data, the data that came from government or taxpayer-funded sources, we saw that it was about 4.7 meters in terms of its accuracy for this. So the point being is that we can actually take relatively cheap crowdsourced data that wasn't really intended to be used that way, anonymized data, so we're not really identifying individuals in this case, and we can aggregate this to come up with relatively high resolution elevation data that can contribute back to the open geodata community. The sort of side part of this is that in certain cases, and I'll actually slow the next slide as more reasonable. In certain cases, LiDAR data, which is laser imaging from the sky in terms of aerial LiDAR, hits things like an overpass, right? So this is a slide just showing an overpass in the black dots there. You can see that this is a road that goes underneath. And then our in situ elevation data actually is the blue line, shows a more reasonable slope rather than the highway overpass that we see in the LiDAR data here. So there are some sort of supplemental ways of that this data can be useful other than just being a replacement for LiDAR in this case too. So back to the OpenStreetMap part of this. Part of this project was to say, well, we got this elevation data, now we should contribute it back to the open source community and provide some better elevation value to this. And that's what we're doing right now, is we're uploading this data to OpenStreetMap. If you go to any of the segments that we've done so far, we've added a tag ELE for elevation, and then the elevation value in meters for that area as well. And then if you look at OpenStreetMap works in terms of change sets, it gives you the provenance of the information, where it came from, how we came up with the value that we did, and so on. So we're contributing it back to it in that way. The other side is that we're actually, the difficulty with OpenStreetMap is, for one segment for OpenStreetMap, we may have had about 300 nodes that make up a single segment. For our data set, because it was higher resolution, we had about 3,000 nodes that made up that segment, right? It was every 1 meter that we had a node for representing this. And we didn't want to overload OpenStreetMap by uploading all the data we had. We just wanted to upload the nodes that they already had in their data set. And so we released a secondary data set that had all of the high resolution information as linked data that we linked back to the OpenStreetMap data set. And anybody can have access to this, and it's publicly available and published online. We just didn't want to overload with too much information, like the minimum elevation and the maximum elevation and some of these other features as well. So, all that being said, I'll get to the summary of the sort of whirlwind of what I just talked about. Basically, as this is a good community to talk to from an open source geospatial perspective, OpenStreetMap is this rich source of geographic information. If you're ever looking for really high resolution road building boundary data sets for your own work or own research, check out OpenStreetMap. It's very rich and robust from comparison to a lot of the existing data sets we've seen. In many ways, it's more up to date than Google or Bing Maps or Yahoo or Apple in that case. For specifically for parts of the world that aren't the focus of commercial enterprises. It's got a lot of really rich data there. A lot of OSM is missing elevation data. That's kind of the reason we wanted to do this project, is provide elevation data to a lot of the OpenStreetMap community. And this is really proposing a sort of unique and really low-cost way, rather than flying planes to collect this information and return this back to the open source community. And we published this via linked data as a linked data tenants to publish this data online in this case. And the last thing I kind of want to mention is sort of wave the flag again for the OpenStreetMap community, is sort of get out there and get involved. There's a lot of projects that are happening on campus and outside campus as well that are focusing on contributing to OpenStreetMap. Missing Maps is a great project. American Red Cross really focuses that. In DC, there's a couple really good meetups for the American Red Cross and Missing Maps. Youth Mappers, we're in the process of actually getting a Youth Mappers chapter on campus. I know the Geography Club in the Geographical Sciences Department is trying to get a Youth Mappers group together, where once a month they have these mapathons where people come together and eat pizza and sit around and map places that are in need. Last week there was a Let Girls Mapathon. I was out of town, so I wasn't involved in that. But that was organized by the Geography Club as well, and trying to get women out to participate in OpenStreetMap projects and get involved. So if you're interested in any of this stuff, I'm happy to talk about it further, but just check it out. OpenStreetMap's a really cool community and really helpful people that gets involved in this kind of work as well. All that being said, I'm done. Thank you very much.
And you're open for questions.
Yeah, absolutely. I'm definitely open for questions.
What kind of use do you think that this would, could be utilized for campus traffic, like foot traffic or bike traffic, especially because some of the roads around here aren't great for bikes?
Right.
Would there be a use for that, or have people looked into mapping campus for bike traffic?
Yeah, there's actually quite a bit of like all the bike friendly roads or the bike trails have been mapped in terms of the traffic, in terms of like where there's potholes and things like that. There are projects that look at that bring in OpenStreetMap and say, hey, there's an issue here, or there's a blind corner here and we should update that. OpenStreetMap themselves, actually, they release their own cartographic map of, it's called the Cycle Map, Open Cycle Map, where they highlight biking trails. And that was one of their things, was to say, we're going to take, you know, things like buildings and sort of push them to the background of the stylistic spectrum and pull forward the cycling maps and stuff like that. And in this general vicinity, in this sort of DMV area, there's some really good bike maps on OpenStreetMap. I would say in many cases better than the sort of big Google bike maps that you can see up there as well.
I can find that cycle map.
Yeah, if you just go to openstreetmap.org, if you go to the right-hand side, there's a layers button, and you just click that and say Open Cycle Map. It'll show you everything that's there too.
Thank you.
Yeah, you have a question?
Yeah, so I want to know some more about you're publishing that data as linked data. I'm very much behind linked data from a theoretical point of view and application, but sometimes I don't always see the practical application. So how are you using linked data? How are other people using the linked data that you publish?
Sure, yeah. So there's a project that has taken all of the OpenStreetMap data and published it existing as linked data. It's called Linked Open Geodata, I think it's called. And so the goal of that was similar to how Wikipedia has DBpedia, which is the structured version of Wikipedia, so that you can link things like Wikipedia articles to geographic locations and do it that way. So what we're trying to do is then, as part of the linked geodata, the nodes that are linked that we know of in that data, we're linking our data set back to them and asking them to do the same. So we have that transversal property where you can say, I want to find the elevation of this node, but I want to find the elevation of sister nodes to the left and right of it. So the reason mainly for this was that we would have something that would meet the specifications if you were to do a GeoSparkle query or search through this data. We have the means to do that by offering sort of traditional geographic linked data, and then linking it back to the existing sources, which are the sort of standard linked geodata, open geodata source code in this case. So our main thing is I'm sort of a big believer in the sort of linked data framework or the tenets of linked data, and so I thought this would be the best way to sort of publish this and get it out there. I'm not sure if that totally answers your question.
Well, so how often do you pull down other data sets that are linked data and then you use that in some way?
So I actually do quite a bit, because a lot of the work that I do is sort of in DBpedia world and linking that to the linked open geodata world. And so as new rolling versions of DBpedia come out, I'll try to link that to whatever updates I have from the OpenStreetMap community. I realize from a sort of typical user standpoint, it's a lot more complicated than that. We do have some platforms right now that we're developing that are sort of a faceted browser for linked data, but specifically for geodata, so that a typical user can go in and write a query that they don't have to know how to write Sparkle, and they can actually do a search for it and see the geographic representation that's been linked through to the textual representation in DBpedia, for example. And so we are doing projects in that area, trying to sort of push that forward as a measure for doing this work. But it's like anything, trying to get people to adopt this is a different side of the coin as well. Yeah.
Well, I have a couple of questions, but the first one is this being archived somewhere? Are they taking snapshots of the data, and how often are they being taken, and who's actually supporting the archive? As the first question. And second, are people, as they update it, I'm thinking about places where possibly natural disasters happen, or bombs, etc., so that you can see elevation before and after, because elevation would definitely change, or fires, or whatever.
Yep.
And are people using it for that? And
No, it's a good question. To your first question, yes, it is there are snapshots being taken. I think at this point it's like monthly snapshots that are being taken. The storage, like the retrieval or the distribution of this, is pretty widely distributed. I know of at least 10 different universities or government groups that are actually storing these snapshots and making them available publicly. A lot of this information too, if you look at, there's a lot of these projects like Mapbox and Stamen Maps, and different companies are actually using this commercially, where they take the underlying data and they'll make these beautiful stylized maps and then sell them or work in that area. So they're incentivized to keep these up to date and store back repositories of this data as well. So there's definitely a curation process for this, absolutely. And that sort of video I showed you before is based on those snapshots that they've had since 2006, uploading that data. The second question, Not that I know of at this point. I know people will use OpenStreetMap. There's other projects that will reference points on OpenStreetMap in terms of the timeline of where events have happened and what has happened. In terms of like the elevation values, that's a project, that's an idea that we were toying around with. The difficulty we're finding is that we just don't have enough data from like user-generated sources to compare, a reasonable time frame for what we're looking at. I think there probably are sites where you would see that big difference in like a year or even a day if there was like a massive landslide and you had that. It typically is not where people will go and ride their bike or go for a run in that area. There might be areas that I just haven't even thought about that I should focus on in that case. But I haven't done anything in that area. I think it'd be really interesting if you had that kind of data to dig into that and see what's going on. Absolutely. Yeah.
So it's, when I, first read the title of your talk, I was sort of imagining like this would be magic with like a Fitbit, right?
Right.
But it sounds like it's a little more advanced than just, walking around, counting your steps. Like you have to have that cycling or something level of computer or GPS option.
Yeah, the social aspect is kind of the key part of that, in a social sharing aspect.
Got it.
Is the kind of key point to it. And it's not like the standard Fitbit that is out there is great for counting steps, but it doesn't have elevation value. It doesn't have GPS built into it. Other devices do, but those are slowly coming with usage of GPS into new devices and new ways of using it. But it is very much reliant on publicly available or user-contributed content that's just out there. And sort of a lot of the work I do is really focused on extracting geographic information from non-geographic entities. So like text, I do a lot of stuff where we look at the usage of text and the kind of geo-indicativeness of words. Like if you say potato, there's a higher probability you're in Idaho than other states. Kind of that kind of idea. And so this was kind of a sort of a project outside of our area that looked at, can we take this mass amount of data that's really noisy and really messy and actually make some useful inferences from it? Yeah.
So when you publish the data, is that a link from your website or something more?
Right now it's a TTL file on the website that I'm pushing out there. Our goal is to push this into the linkdata.org. They have a curation of all the different data sets, and it requires that you have, I think, 100 links to other existing data sets in order to be published as part of that Link Data Cloud. And so that's the goal, is once we have a much larger scale of this will link quite clearly into the linked Open Geodata, as well as hopefully the Wikipedia or DBpedia content as well. Great. Oh, yeah.
This is totally off the wall.
Great.
Okay? I work in dance, in the performing arts, but I've been wanting for years to be able to really study people moving vertically
Sure.
and horizontally and sagittally, and trying to track that kind of data, which is a little difficult to actually gather. We use relatively static motion capture systems. But trying to use some of these to find out how people are moving. And the other thing that I've done, just brought up, is looking at the words that people use to describe this type of movement and connecting what does it mean to jump versus what does it mean to bounce versus what is kind of thing, all of these words. But you're making me think about that type of research, even though it wouldn't really help people out in the world, I don't think. It would be really fascinating to find out, to eventually be able to study this in a great way. And the data, I'd have to figure out that. I may come bug you at some point.
Yeah, no,
just to
absolutely.
say, how could we, what tools could we use? And we've used Wemos,
Right.
real Vicon motion capture systems, and more recently iPhone.
Yeah.
So,
I mean, a lot of the stuff that I've seen really is in the sports world, right? So there's a lot of these like basketball or soccer tracking devices and increasingly you'll have like Bluetooth chips that you'll have on different parts of your body that will allow you to see actual movement. The finer resolution of Bluetooth low energy is getting really good. But I think the language stuff you mentioned is kind of interesting, because I'm curious to see how that works. If you have like a long descriptive text about some long dance piece that you had, could you identify the different
Yeah,
parts
I
of
mean,
that?
you
Yeah.
get a corpus of,
Right,
of
right.
facts about dance, and then you just go through and start looking for the
Yeah,
words
yeah.
and the frequency of them.
That would be
You look
interesting.
at perception, what, people who are writing about it, how are they perceiving it? and
Sure.
Then talking about it.
No, it's an interesting idea, yeah. Very cool. Yeah.
I had a question about using, with the Fitbit. One of my sisters has one, and it detects when she's going uphill, gives her credit for going upstairs, but not when she's going downhill. Now, so how would that work for detecting elevation?
Well, the Fitbit you're talking about probably doesn't have a kind of GPS sensor, or it may have a barometric altimeter, or it may just be doing that. They have some pretty smart ways of determining that based on how fast you typically walk, and then if that changes, so you can tell if you're going uphill or downhill. Some of those work, some of those don't, but some of that's that part, right? If you're going downhill, are you able to determine what your cadence is of your step, and does that indicate that you're going faster or slower than you were before? Barometric altimeters are not the be all and end all, because they're so driven based on pressure, right? So any change in pressure it will change what your elevation is presumed to be. And so you often will find, right, if you go for a lot of us have probably seen that we've gone for a hike, we take a GPS unit with us, we get back to the start and it says that our elevation change is like 50 meters. And we're just standing at the exact same place we were before. And it's just a technological limitation right now that I think that's going to get better and better as we have more, GLONASS and some of the other satellite systems are increasing better precision for our values there.
So this program here is taking an average from a whole bunch of people's reports.
Right, yeah, we take on aggregate just 10, 20, 40,000 different activities, and as a whole, you get a much better representation than you would as a single individual. Great, well, thank you very much.
Yeah. So, this was a very interesting talk. I want to thank Grant for this inspirational talk, and just wanted to mention that many years ago, for those of you who have been on this campus for longer than Grant, you remember that there was a map, campus map, that was pretty colorful but ridiculous, and Gemstone team took on themselves to create a map that was wheelchair accessible. And I was the librarian for that Gemstone team, and that is the precursor of the current map on campus. And when they were working on that map, they were actually walking on wheelchairs, pushing wheelchairs around campus to identify what are the, so we've gone long way since those days.
Right, absolutely.
And for a token of appreciation, I wanted to present you with this mug, which is hot off the press. You are the first one that is getting
Wow,
this.
I feel honored.
Yeah.
Well, thank you.
Yeah.
Thanks very much.
Oh, you're welcome.